Hello everyone, welcome back to my new video. I'm today with the topic of basic maths only. In the previous topics we have discussed about the trigonometric angles and their identities. So now let's see some angles approximation which will help us to solve the problems more quickly. If the angle is less than 5 degree, then we can use these approximation as stated. Okay, if sine theta is means when theta is less than 5 degree, then sine theta can be written as theta and theta must be in radians. Cos theta if less than 5 degrees, then it can be written directly 1, and tan theta can be written theta directly, but in both these cases theta must be in radians. Okay, now let's see the examples. Sine 1 degree. Okay, so now first we will convert it into radians. For converting it into radians, we have to multiply it by pi by 180. So 1 into pi by 180 will give us pi by 180. So approximately sine 1 degree is equal to pi by 180. Sine 2 degree is equal to 2 into pi by 180, which is approximately equal to pi by 90. Similarly, tan 2 degree, tan 2 into pi by 180 is approximately equal to pi by 90. Now cos 3 degree. So it is not necessary to convert the cos 1 into radian, because we directly have to write it 1 only, whether we convert it into radians or not. So cos 3 degree is approximately equal to 1. Okay, so now second part of basic maths is coordinate geometry. Okay, we all have learned about coordinate geometry from I think 6th or 7th class. Okay, so today also I am going to tell you some basics and some new things also. Okay, so first is position of a point. Let it be x comma y. So x comma y, let us consider this point 2 comma 3. So what does this denote, or what does this say? It says that the point 2 comma 3 is 3 units away, 3 units from x axis and 2 units from y axis, or can say like x1 is the perpendicular distance from y axis and y1 is the perpendicular distance from x axis. And also this first point is generally is x coordinate, also called abscissa, and y coordinate is also known as ordinate. Okay, now let us see the another thing, which is how to find the distance between 2 points. Distance between 2 points is calculated with the help of root over x2 minus x1 whole square plus y2 minus y1 whole square. Let us understand how is this derived. Okay, see, this is point x1 comma y1 and this is x2 comma y2. Okay, we have dropped the perpendiculars from both these points and find these distances. So this distance is x2 and this distance is x1. So see, this, there is a triangle being formed. Now this is the right angle triangle also. So we know that perpendicular square plus hypotenuse square plus base square gives us hypotenuse square. So base will be x2 minus x1. See, this base will be x2 minus x1 and height will be y2 minus y1. See, whole is this this is y2 and this is y1. So this will be y2 minus y1. So that gives us x2 minus x1 whole square plus y2 minus y1 whole square is equal to, let this be d, which denotes d square. So that is how we got d equals root over x2 minus x1 whole square plus y2 minus y1 whole square. Now let us learn slope of a line. Slope of a line is basically the theta 1. Okay, this is the slope of this line. It is calculated by the theta only. M is equal to tan theta is equal to y2 minus y1 by x2 minus x1, or we can even write it like y1 minus y2 by x1 minus x2. Okay, but we have to remember that the first coordinate, like if this is y2, then denominator also first should be the x2 one. Okay, not, you cannot write like y2 minus y1 by x1 minus x2. You have to write it in this manner or this manner. Okay, now next thing comes is graphs. Okay, graphs are basically diagrammatic representation of relation in between two physical quantities. Nature of the graphs depends upon relation in between two quantities, and there can be infinite types of graphs but on the basis of their nature we classify them into 8 varieties, out of which we are going to study 7 varieties in physics. The 8th one is about log, which we will use in chemistry. Okay, first one is straight line graph, and its equation is y equals mx plus c, where y power of y should be 1 and power of x should be 1. Now c here represents the intercept on y axis and m represents the slope. Okay, this m represents the slope because it is the tan theta only, and theta is the slope angle. It is the angle made by the straight line from positive x direction. Positive x direction means this x positive direction. If even if it is in the negative side, then also we take it on the right side. If it is on the right side, then it is the positive side only. Let it be on the negative side also. Then also, it is measured in the anti-clockwise direction from positive x axis direction. It is not the x axis positive one. It is the direction. Okay. Now possible values of m. When m is positive, then tan theta will be positive, which means that tan theta will be less than 90 degree, because from the ASTC rule we know that in the first quadrant all the angles are positive. Okay, so when m is positive, theta will be less than 90 degree, so line will be like this. When m is negative, theta will be greater than 90 degrees, so line will be this, like this, because see, y and x axis are perpendicular to each other, and if it crosses it, then it is greater than 90 degree, so line will be like this only. When m is 0, so tan theta will be 0, so line will be parallel to x axis. When m is infinity, we know that tan 90 is infinity, so theta will be 90 degree, so it will be perpendicular to y axis. Okay, now possible values of c. What was c? C was the intercept on y axis. So when c will be positive, it will intercept above 0. Okay, when c will be negative, it will intercept below 0. When c will be 0, 0 means what? It will pass through the origin. Simple. Let's see two questions here. See, we have to draw the graphs for the following. See here, y to the power 1 and is equal to 3x and power is 1 plus 4. So here m is 3, which is positive, c is 4, which is also positive. So line will be like this, because c is positive, so it will be above x axis, and m is positive, so theta will be less than 90 degree. Okay, so line will be like this. Now second example, y is equal to 2x minus 5. Now m is positive here, but c is negative, so y intercept would be below x axis or above x axis? Yes, it will be below, sorry, y axis. It will be below the origin in y axis. Okay, so line will be like this since theta is less than 90 degree. That's all for today's physics. Thank you. See, in the alveoli or air sacs of lungs, this is a basically structure where pneumocytes 1 is present. Pneumocytes 1 are present in 95% of the area. Okay, this is basically structure of alveoli. Now next is Bowman's capsule. See here, Bowman's capsule. The cells present there are known as podocytes. You must remember these names, pneumocytes 1, because we are going to study pneumocytes 2 also. That is why I am telling. Podocytes in Bowman's capsule. Now thin part of loop of Henle. See, this is thick part of loop of Henle and this is thin part. Okay, so simple squamous epithelium is present in thin part of loop of Henle. Okay. Now as we discussed about outer surface of intestine, endothelium of blood vessels. In endothelium of blood vessels, tessellated mesodermal epithelium is present. See, this blood vessel and tessellated type of epithelium is present. Next is endocardium of heart. Here also tessellated mesodermal epithelium is present. Okay. Now next comes is mesothelium or peritoneum. See, this is our body basically. This is the mouth and this is the anus. The pathway from mouth to anus is also known as gut or alimentary canal. Now we are going to take a cut and to look through its dissection. So we will get the structure as this. So here and here, both of these areas, it is simple
squamous epithelium. Okay, this inner layer is formed with the visceral epithelium and this outer one is formed by the parietal epithelium. Both together are known as mesothelium. Okay, this is also, this space, empty space, is filled with coelomic fluid and also called as body cavity. Okay, now next comes is simple cuboidal epithelium. Its function is absorption and secretion, also known as germinal epithelium, because it gives birth. Let us see the examples. First one is alveoli, air sacs of lungs, pneumocytes 2. There we have discussed pneumocytes 1 and here it is pneumocytes 2. So simple squamous epithelium is present in 95% and simple cuboidal epithelium is present in 5% or pneumocytes 2. Okay. Second one is follicles of thyroid gland. See, in thyroid gland we are taking a single cell, this is called as follicle. Okay. So here cuboidal epithelium is present, this thyroid follicle. Okay, next is acini of pancreas. In the pancreas we are taking a small part of it. Okay, so we'll get a structure like this and this is the simple cuboidal epithelium. It is filled in the whole space. Okay, next comes is secretory unit of sweat gland. Now this is our sweat gland and basically this is the secretory unit and this is the duct. Okay, so its function is secretion also, so it secretes the sweat. Next is thick part of Henle's loop and DCT of nephron. DCT is basically distal convoluted tubule. Okay, now next are iris, choroid, ciliary body and retinal epithelium. All of these four things are present in eye and you can find simple cuboidal epithelium cells. See, this is our structure of eye. Outer portion is known as sclera, then comes choroid. Okay, then inner one is retinal epithelium and this is iris, the elongated one, and this is the ciliary body. We will discuss about all these functions in the coming videos. Okay, now let us see the next thing. Now there are modifications in cuboidal epithelium also. So two modifications are basically there. Simple brush bordered cuboidal epithelium. See, here also brush bordered kind of thing is there. It increases the rate of absorption and also surface area. Okay, it is found in the PCT of nephron because from there we have to absorb a lot of things. Second one is simple ciliated cuboidal epithelium. Okay, see, this is cuboidal epithelium and this is cilia. So it is found in collecting duct because cilia helps in providing direction to something. Okay, whether it be upside, downside, anywhere. Okay, so that's all for today. Thank you.